So just to introduce, my name is Vinay, and I'm the CEO and founder for Arya.ai. So one of the products that we recently launched is called AryaxAi. It's primarily an ML observability framework for your mission critical AI. I mean, in the previous sessions, you have been hearing about how they have used AI and deployed models, right? But so far, if you look at the architecture of these models in production, there is no safety layer around this, or it is kind of silos or point focus from that standpoint. So what actually happened in the last decade is it became quite easy to build any AIML model. It could be a simple linear regression model, or it could be a deep learning model, right? It became quite easy to deploy models in production today. But the question is it safe to deploy these models in production? So this question is really important depending on what use case you are deploying these models for. Particularly if you are an enterprise, you would have a lot of questions around safety, governance, explainability, transparency, auditability, and a bunch of things primarily. If you actually look at the models in production, they fail more often than you think. Yeah, so there is a paper that talked about temporal degradation of these models. So what is observed is when they looked at more than 20,000 plus models, the models start degrading. More than 91% of these models started degrading. So this is actually a realistic problem. So when I put a model in production, assuming that the model will work as much as what it was performing in your training data sets or your test environments, it's actually not a reality. And there are many reasons why these models fail in production. It could be very fundamentally, there is a data drift, meaning the data sets that you have trained during training versus production is entirely different. Or the models may be having some kind of model drifts and all. So these are very basic problems in terms of when you productionize this model. If you talk about LLMs, everybody has been talking about safety layer, governance layer around these models. But the problem generically with generative AI is, I could actually hack these models, extract training data sets, for example. They are not explainable. There are a bunch of challenges why these generative AI models are really tough to use in production. And another intrinsic problem is these frameworks or architecture that people are deploying these models, they are not intrinsically explainable, right? Meaning it can give you a prediction, but when you ask and try to probe the question around why the prediction is that prediction and all, you would barely get an answer in terms of how these model has worked. So this could result in a bunch of issues when you put models in production, from issues like wrong predictions, model drift giving wrong credit scores, for example, and all of that. So what enterprises looks for is, let's say you have AI/ML model, so they are looking for a safety layer or an ML observability layer around that. That's actually is the ML observability. From a conceptual standpoint, it's actually not new. Like Datadog or for example, New Relic. So you have software observability already established. Now we are talking about observability around machine learning models. So that's where we come in. AryaxAi being an ML observability layer. So the way that we looked at this problem is, if I put these ML observability in AI/ML production environments, can these framework help me to identify the gaps, which is primarily around model diagnosis, and help me to figure out how to fix them, model prognosis, for example. So that's what this AryaxAi serves. It sits on top of your MLOps framework. So you could be building models in DataRobot, Histo.ai, AWS, it could be anything. We don't care. So you could simply plug in AryaxAi to the MLOps framework and bring in all these components as part of a plug and play kind of framework. So just to quickly give you a few more details, for example, from an ML explainability standpoint, we have our own proprietary method that could actually explain deep learning models, which is more stable, more accurate as compared to Sharp or Lime, for example, which is, so they could actually change as per the baseline and everything. Second is beyond feature importance. We actually look at a broader set of explanation. So we also have introduced a concept called decision flow. Whenever a model is making a prediction, it could actually visualize the decision in a simple, very visualistic manner. And what it means is, let's say this is your traditional MLOps output. So I have a model in production. That model output is simply the model prediction confidence score, something like that. Whereas when you plug in AryaxAi, you would get a bunch of explainability in addition to your model prediction. So this is where we get differentiated heavily. For example, if I want to put a model in, let's say, an underwriting problem, an insurance, in diagnosis, autonomous cars, for example, I cannot have simply this as the output. That barely, even though models could be accurate, but that's not at all transparent, right? Whereas on the other end, we could give you a bunch of explainability that you can actually showcase in your own apps through real-time APIs, for example. In addition to this, we have very detailed ML monitoring interface. So where we would track data drifts, target drifts, bias, and model performance, for example, where you could simply define your threshold and start getting alerts for these things. And another layer that we introduce is called risk policies. So for example, as a business, I have a condition that my AI should not give biased decisions, or I don't want to process transactions which has a certain value as a straight through, for example. You could actually start doing stress testing on your models to figure out where your model risk is coming to, your AI usage risks, for example. That could be a business risks or model performance risks and all of that. So our framework can plug into your data feature store and the models directly, where the user can simply define these risk policies, the risk policies for using these models in a simple GUI. And we can deploy these policies whenever model is making a prediction, for example. So I quickly show you how it looks like. So this is a quick interface in terms of the model prediction path. So you could see the future importance, for example, as an explanation, and we could actually convert these into simple text such that your end user can start looking at the explainability in a simple text, for example. And this is the prediction path that I talked about. You could see and navigate the contrasted predictions as well in terms of how your model has varied and all of that. So all of this is coming from surrogate model in this case, whereas if you're using deep learning models, so you could leverage our proprietary algorithms for explainability, for example. And when it comes to ML monitoring, so I quickly show you ML monitoring and then I'll move on to the final one. Yeah, I think this is getting loaded. Yeah. So here I have created a ML monitoring dashboard on my test and train data. So I'm using the entire feature set and I'm using PSI as a metric to track my drifts. You could actually change and pick up any metric beyond PSI as well. So you have we have chi-square text, jet test, was it in distance, scale, divergence, for example. These are the different methodologies that you could use for tracking drifts. So here you could see, I have done the drift analysis for more than 105 features, out of which 28% of the features have data drifts in these features, for example. So you could also see a quick visualization in terms of how the data varies between your current and training samples and all of that. So this is primarily for monitoring purposes. And this is our ML risk policy layer. So you could see that there are different risk policies that I've created and all of that. So far, this is the standard components that we have added so far already to our ML observability framework. Now we are introducing a new component called AryaxAi synthetics, wherein you could actually deploy GPT-2 or GANs on your tabular data so that you could create a very high quality synthetic data sets. So one of the discoveries that we made is, if you actually want to make better alignment of your models, right, you need a lot of feedback that you have to give to the models. One, you may not be able to generate that feedback in realistic environment, but you could do that when you have a synthetic environment. So now we are able to allow our customers to deploy very complex GPT-2 models or GAN models simply by plugging in your datasets. For example, so this is the synthetic AI interface. I think it's just loading up. Yeah, so these are the different, these are the two options that we have. One is GPT-2 and CTGAN. Beyond this, maybe we will use LLM as a base for training your tabular datasets. But at this point of time, GPT-2 is fairly very, very accurate. Meaning you could actually plug in your tabular data into GPT-2 model and create a synthetic model out of it, which is also quite fast in this case as well. You could train the models and you could see the performance and everything, column shapes of your synthetic datasets and all. It could actually track the training as well. And then when it comes to synthetic data generation, you can simply define how many columns that you want, how many rows that you want to generate, and it can start generating those number of rows. So we also introduced a concept called prompting. So for example, let's say I have a lot of tabular data, but I wanted to create false positive data only, or data for where FICO score is more than 750, for example. So now you want to define conditions on sampling before creating synthetic data. So you can actually use those, define them as prompts, and post training the model. So we would use prompting layer and create the synthetic data out of it. So synthetic AI is as a component in ML observability is going to be really important because we believe that you could actually have a better AI alignment, as I said. And there are more new ways that we are trying to figure out how we could leverage synthetic data as part of this. And the problem that we are trying to solve is, as the industry is focusing on coming up with new techniques, each technique will have their own intrinsic risks, right? For example, LLMs, everybody is now kind of educated about what are the risks around LLMs, for example. Tomorrow, there could be a technique like maybe full AGIs, for example, or something else, or synthetic AI, for example, or something else. Each technique comes up with risks, and that's where we come in. So if the industry is building the blue pill, we are building the red pill of the industry, so that both of us can work together and make the technology usable, acceptable, safe, and secure, and scalable for all use cases beyond simple traditional use cases. It could be medical diagnosis, autonomous cars, space, for example. So a lot of use cases are sensitive, so that requires a safety layer or a safety net for the industry. So that's what we are building today. Yeah, so that's the problem that we are trying to solve, and we are at booth 115. And whatever the components that I've talked about, all of them are in production. All of them have been used in the industry. So if you are someone who is looking for it, so please do drop by. We would be happy to give you the access and all. That's all from my end, guys. Thank you.